Hi, it's me TOC from Silver Star Studios, and I welcome you to another interesting episode in physics. Today, we will be deriving the three equations of motion. These equations consider objects or a moving body along a straight line path. All these three equations consider the following factors: initial velocity in meters per second, to final velocity also in meters per second, acceleration in meters per second squared, time in seconds, and distance in meters. So let's take a look at the first equation of motion. If a body at rest or already moving with an initial velocity u in meters per second begins to accelerate with an acceleration a in meters per second squared, after a particular time t in seconds, it will obtain a final velocity v in meters per second. So the acceleration a will be defined as a is equal to change in velocity all over time taken to make the change. But we can also always remember that change in velocity is the difference between the final velocity and initial velocity. So change in velocity is equal to final velocity v minus initial velocity u. So the definition for acceleration will be equal to v minus u over t, where v is the final velocity and u is the initial velocity. And if we cross multiply the equation, a is equal to v minus u over t, we will have that v minus u is equal to at. Now let's make v the subject of the formula. Minus u will cross the equation sign and become positive. So we have v is equal to u plus at. This is the first equation of motion. Now let's take a look at the second equation of motion. To derive the second equation of motion, we will have to consider a body moving with uniform or constant acceleration. This body must have attained an initial must have had an initial velocity u and attained the final velocity v. So hence the average velocity is typically the sum of the final and initial velocities divided by 2. Let's make a mathematical representation of this statement. We have that a, average velocity, is equal to v plus u divided by 2. But in equation 1, we say that our velocity is equal to u plus at. So if we substitute the average velocity v is equal to 2u plus at in the above equation, which is v plus u over 2, we will now have that average velocity is equal to u plus at divided by 2. If u plus at divided by 2 is equal to average velocity, this implies that 2u plus at all over 2 is equal to average velocity. Hence, 2u over 2 plus at all over 2, you divide out, you have that u plus at over 2 is equal to average velocity. U plus half at is equal to average velocity. But in our first episode of physics, we defined that average velocity is equal to distance or displacement over time. Displacement is in a specific direction. So we have that s over t, which is our average velocity, substituted in the equation u plus half at. So we cross multiply out this equation. S over t is equal to u plus half at. When we cross multiply, we will have that S is equal to t bracket u plus half at. If we remove the brackets, we have that S is equal to ut plus half at squared. This is the second equation of motion, presumably used to compute distances, determine the distance of a body given initial velocity, acceleration, and time. Yeah. Now let's take a look at the third equation of motion. The third equation of motion is a combination of the first two equations of motion. Is a combination of the second and first equations. So let's begin by squaring both sides of the first equation. V is equal to u plus at. So if we square it, we have that v squared is equal to u plus at squared. If we expand the bracket, we have that v squared is equal to u plus at bracket u plus at. When we multiply out, we have that v squared is equal to u squared plus uat plus uat plus a squared t squared. Now we add up like terms. We have that v squared is equal to u squared plus 2uat plus a squared t squared. This implies that v squared is equal to u squared plus 2a over 2a bracket 2uat plus a squared t squared. Now we start to factorize out. We have that u squared, v squared is equal to u squared plus 2a bracket 2uat all over 2a plus a squared t squared all over 2a. We cancel out by 2a, bringing 2a out as a common factor. V squared will give us u squared plus 2a bracket ut plus half at squared. We have that we try to substitute equation 2 from the above expression. Hence, v squared will be equal to u squared plus 2as. This is the third equation of motion. Okay, having derived these equations, let us summarize what we've done so far. The three equations of motion are: 1, v is equal to u plus at. 2, s is equal to ut plus half at squared, and v squared is equal to u squared plus 2as. It is also important to know that what these values or letters stand for. V stands for final velocity, u stands for initial velocity, a stands for acceleration, t stands for time, where s stands for distance. The SI units are also very important. V, which is final velocity, is measured in meters per second, initial velocity meters per second, acceleration also in meters per second squared. Time is measured in seconds, and distance is measured in meters. Meters per second squared is measured in seconds, and this one is measured in meters. Also note that when a body accelerates from rest, its initial velocity is equal to 0 meters per second. When it comes to rest, its final velocity is equal to 0 meters per second. Also, when acceleration is constant, it simply means that acceleration is equal to 0 meters per second squared. Don't forget to click subscribe on our YouTube channel, and also follow us on our Facebook page for more interesting episodes. See you with the calculations coming up in episode 3.